Good morning. I know this song. Do, 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 do. It's one of those little plinky coffee house alternative songs. What is this? Oh God. Do, 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 do. Ah, that's gonna bother me. Morning. You have it in the comments anywhere? Oops, no. Okay. Oh, these are just the artist cover. Oh, what's that beat? Oh God. I'm gonna remember it in like 2 hours. Okay. Wow, this is the most positive YouTube comment section I've ever seen. Dang. And here I just put it on because it's raining out. Or is that an Eminem song? No. It's a Macklemore song, that's what I'm thinking of. Okay. Figured it out before class. That's right, okay. That's it.
Third grade, I thought that I was gay. Okay, sure, but you're still years ago.
Where's the chorus? There it is. Okay. Oh God. That's how today starts. Alright, there's that beat under the lo-fi remix there. I was gonna get stuck in my head all day. How was everybody's weekend? Assuming we're all here. Yes, thank you, Java update. Bot spam, ping the right people. Good. Right. You go over here. Very busy. Mine too. Mine too. A lovely storm outside today. Yeah, for whatever reason. So I'm also running a class right now on Google Cloud stuff. And I don't know why, but they decided to muck about with their servers over the weekend, like their coupon granting servers. So all of my 680 students that were trying to get a homework completed were realizing they couldn't get any coupons for the cloud. And that was fun for them and me. Yeah, so I dropped this guy's YouTube channel into the School of Computing Discord coding train. I have been watching these videos just for fun. This guy is like his enthusiasm is infectious, but it kind of plays with some of the little P5 JS stuff that I've been dinking around with outside of class. Like he's got this thing on whirly noise, which is just a noise function. It's just, he's good. I like him. Okay, it is 9:01. So let's get to class. So I haven't checked your assignments yet that you submitted, but thank you for getting those in. I'll give you a couple days breather before I give you the next one. I believe the one that I normally give next is actually a programming assignment. So look forward to some fun with that. Let's see, anything else? I've got up on Blackboard, there is a in-class assignment that's going to be due tomorrow, so we will have a little bit of Discord time today. We'll get to that towards the end. Actually, no, sorry, we have two of them broken up. Just trying to remember which way I want to have this set up for you all. But we stopped last time with Singleton, right? So I was kind of going over the ins and outs of this pattern. We didn't really go into the exact programming of it yet, right? But I showed you the UML diagram here, and we can get a feel for the fact that this thing is only ever going to be instantiated once. We can have copies of the instantiation, but just one copy, right? So let's see. Oh, this is where we ended. That's right. Looking at my last year versus this year start here notes. Anybody remember from Java 1 days what the difference between private and protected variables are? Because this kind of factors into how some of our design patterns work. Let's go. Anybody remember? Private versus protected. Party parrot. The sky sounds very angry outside. Private's only accessed within the class that defines them. Private can only be accessed by internal. Yes, Mikkel, you got that absolutely right. So first two of you got it halfway there, and then the last one is absolutely correct. So private only available within that class. Protected, if you have, say, a child class, that means that those methods are also accessible. So let me pop back here. So this would be a single class. However, if we instantiate a subclass inside of the singleton, for instance, these methods and properties would all be available if we made them private. So, absolutely right. And then the other side of things, which we didn't have there, public, anybody can access it. Now this, just as a bit of a refresher, goes into data hiding and protection. Basically, you don't always want methods and parameters accessed by everybody. Now, can you get by with making everything public? Absolutely, even for complicated programs. But sometimes you want to ensure that variables are not manipulated outside of your local class. Maybe you have, for instance, a design pattern like a singleton where you need to ensure that there's only ever one instance of this thing in memory. You can do that with, privating and protecting them. And when I say you want to make sure this never happens, you can only ever specify so much in your documentation. If I made everything public, but I said, hey, don't use this unless you absolutely need to, use like the gets and the set functions. Not everybody's going to follow your guidelines if you're working on a team, or if you release something as public in a GitHub repository, for instance. But just be aware that this is, again, going to kind of feature into a lot of our design patterns that we're going to look at. So I mentioned last time that I'm not going to be writing the Java, but we will be looking at the code, and I've got some functioning examples that I can throw up on Blackboard for you all too. But here we have a example in Java. So I've got two singleton children here. We're extending the main singleton class, and the singleton class is right here, if we recall. So public singleton, private instance, protected or private constructor, and then get instance either creates a new instance or returns the existing one. So if we go here now, I can create two children. So singleton child 1, singleton child 2. They both have a call to get instance, and they should return that they are the same thing. So I might have, if we're going back to our random number generator example, RNG1, RNG2, these might be, maybe you want to split up random number generators for random map instantiation, random item instantiation, but they're still going to use the same class. They should be identical in memory. In the Python example, I've got a very kind of light gray here, but if you want the blog walkthrough of this code, I pulled it off this tutorials point page. So I actually can just pull up the singleton code here, where, again, we have some Java-like calls here. You can do object-oriented programming in Python, and this is what I ran last time, right? So let's print these variables, make sure that they're the same thing. So Python singleton. This is what we saw at the end of class last time. Memory, locations, identical, but 3 copies of the object, basically. Get instance is going to create a new instance. Init, this is your constructor in Python. If we already have one, we in theory would raise an exception. However, well, we can do that. So let's try breaking this thing. So let's say S3 equals singleton. Print S3. I think we should get an assertion error here. Yeah. So that's 2 different ways that you could basically handle a singleton, by the way. So what I'm kind of going over here is that with this design pattern, it is up to you, the programmer, to, kind of enforce some of these patterns and these principles. But let's say that I'm working with a team and somebody else decides they want to declare a new singleton instance in their class. Well, I could, there's multiple ways you could handle people breaking your pattern. So fail silently and just return them a copy of the instance, or make an assertion happen and break the program, and then tell them, hey, idiot, this class is a singleton. You should not be instantiating it. Use the getInstance method. Right. So we have that. And what I've also got here too is we can actually, so this I've got commented out. This is a very Python-based thing, so this is not really, I don't think this would translate necessarily to Java or C++, but you can fail silently and just return the same instance and not tell the developers that's what's happening. And that's with the new, let me go ahead and try this here, because I actually didn't try this out when I was practicing. So S2 equals singleton, print S2. Get rid of these guys. Oops. And you don't match the indentation. Okay. Oh, okay, you're off by 1. Yay, Python. Yeah, okay, good. It's always that moment of heart attack when it's been a semester since you've run a demo and weren't sure if it worked. I forgot about this block of code. So what we see here is 2 of the same objects. This is taking advantage of Python's new function. So this is baked into the language if you're working with object-oriented programming. Again, not really a intention of going deep into Python here. But if we have a instance, where again, instance is this internal private variable here, instantiate a new one. Otherwise, just return the instance. I guess return it regardless. So examples are to fail silently or to fail with an assertion. So that is kind of the two different ways that you can handle these things. And I assume that if you are in Java, you could do something similar, right? Return a new instance or trip an assertion. And yeah, I will throw these up on Blackboard afterwards. But what I'd like you to do now is let's take maybe, let's see. So I've got three points here. I'd like you to flip over to your Discord rooms, and this can be for your term project groups. I guess let me give you the option. Do you want to go into your term projects groups, or do you want to do just a generic split you up into 4 groups type of thing here? I'm good with either way. I have the assignments structured for term projects, but I know not everybody always shows up, and I don't want like a team of 1 type thing happening. So let me know what you're thinking here. No preference. Okay. Let's do team project rooms. So I will give you, make sure I have this channel here. All right. So drop into your room. So what I would like you to do is go into your team project Discord rooms, and it doesn't have to be in my server, right? I know that some of you are separate. Basically, when are you going to use a design pattern? And then drop the pros and cons into the in-class discussion channel. So I just created this guy here. Okay, so I'm going to give you, let's say, 5 minutes to talk about this. All right, so let me get you that going. History, please. Raining in Osaka, that worked. All right, 9:20. See some responses in the in-class discussion channel. Okay. And I'll have you drop those into an in-class assignment thing. And if you have questions, please let me know if it doesn't make sense. Assignments. And I'm noticing now that Blackboard is doing that thing where it screws up my ordering. I wonder if I need to do like it numbered. It's in class assignment 5-Singleton is what you'll be turning in. It's this guy. It's here at the bottom. It's trying to shift itself again. So that's just how Blackboard works, apparently. Ooh, voice chat. And you all have been pinged. 1 minute left. Hey, response is coming in. You'll love to see it. All right, it is 9:20. Let's get some answers. So, how would you use the singleton and what are the pros and cons? And I figured it'd be easier to kind of aggregate all this in Discord. That's why I had you jump technologies. Several people are typing. Non-prefab objects in each scene are singletons and not meant to be instantiated multiple times. Okay, I could see that. So what are... So Connor, what would an example of a non-singleton object be? Or sorry, a non-prefab object for you? Like singular items or things like that? Love your profile picture, by the way. I'm not sure if you are going out on stream, just as a warning. Software has been messed up for a while on that. More so for your protection, because it'll be up on the internet. Okay. Mm-hmm. 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 Okay. Yeah. Makes sense. Yeah, I think that sounds good. I was just kind of curious. Okay. Yeah, sounds good. Yeah. So, I was in voice chat there for a second. I'm not sure if anybody heard that or not, other than me, but good use of singletons, it sounded like. So, specific checker scenario. Okay. So, for the scenario, that we'd have to talk about that, I think. I could see it being possible. Never more than one ship on screen. Makes sense. Okay, playable character. Characters are... Depends if you want, so I'm just kind of going in order here. If you're instantiating a character and enemies, is the same base class, then that might be tricky for singletons, I suppose. If the player was separate enough, that would make sense. Singleton player controlled chip, okay. I mean, it sounds like you're all kind of getting the idea, so that's good. All right, pause the music. Good. So make sure that you have these down in a document and submit them after class, or because we've got one more aspect to this activity too, just as a heads up, but it's going to be, yeah, it moved on me again. In class assignment 5, Singleton. And I'm kind of updating it as we go just to see how far we get with these. All right, good. So thank you all for playing along. Full screen, please. Does F work? Why do they say that they're hotkeys and then they don't work? Control Shift F. Now you're gonna work and make me look foolish. Perfect. Okay, so what is going on here? Okay, let's refresh. Am I going insane, or are they just like changing the interface on me here? There it is. I must have clicked something. Wow, okay. Technology is fun. Okay, so thank you for that. Let's talk Facade now, because I want to start moving us along. Singleton's very useful for controlling access to memory, right? Facade is how we control external access to our programs. So this figure that you see here is the idea of a facade, and I'm pretty sure that I think, Owen, you said you've heard of Facade last time. But the idea here is that you have your core system kind of abstracted behind some front interface. So the clients here on the left, this could be anybody. This could be other developers. This could be external users. It just kind of depends on what your program is doing, but you're providing them a single unified interface to work with your backend systems. And kind of the nice thing here with this pattern is that they only ever see the facade. So for instance, if you want to make updates, if you want to change behaviors, swap out functionality, swap out algorithms, as long as this facade doesn't change, they don't know what is different, excuse me, other than what you're telling them. So the example we're going to go through later on is a washing machine example. So the users, if they're going to be, hopefully we keep power here. Let's say we press the button to start the washing machine, right? If you are at version 1 of your washing machine firmware, your software on that thing, and you hit start, well, maybe we're going to go through rinse, wash, or sorry, wash, rinse, spin, or something like that. You could add on a smart controller. Yeah, that was a pretty good one. Storm's got to be pretty close by, huh? But basically, I could swap out behaviors here, right? I could add in a smart controller for sensing the weight of your washing machine load or something like that. Users don't see a difference. So this is a structural class where your system is going to be made up of a lot of complicated pieces behind the scenes. And to the casual user, to the everyday programmer, everyday API interface user, they don't need to know what's going on behind the scenes, right? You can control that. Maybe you always have a common way of doing things. Now, on the other hand, you don't necessarily hide the functionality. You can if you want. Um, but maybe your quote unquote power users want direct access to some of these features, some of these functions. You don't necessarily have to make them private or protected. So let me bring up, let's hold off on that for a minute. Let's take a look at the UML diagram here. So here we have our facade and our nice and pixelated UML diagram. We have some complicated objects here behind the scenes. We have our client. Our client And again, let's think of this in terms of you are a front end user. You've downloaded some kind of a class or a module or a library and you're importing it into your application. So this calls it Facade, but you could call it, say, scikit-learn, or you could call it NumPy, or you could call it Pygame. And basically any of these kind of complex libraries that we use where all of the stuff is abstracted away behind the scenes. I've been mucking about in P5.js lately, right? Where Java's processing is kind of the thing that started that. There are functions in there called setup and draw and image, and those are basically facades to the complicated graphics drawing that's happening behind the scenes. Me as the client, I don't see any of, blitting to a particular buffer and updating the screen. That's all abstracted away from me. So I import facade, or I call facade.operation. Okay, so here is the only thing the client has to do. The facade implements this public operation function, and inside of that operation, I'm going to call a series of functions. Maybe I'm instantiating objects, maybe I'm calling things in a particular sequence, feeding them particular data, but I only have to make one call as the public user, the public developer. The facade handles all the complicated trickery behind the scenes. And this gives you a lot of flexibility in changing up the behaviors if you have to make an update. So here is the washing machine example that I gave you before, where I want to start a washing machine cycle, right? Well, I'm going to, maybe this is just oh, that is a storm going on. Maybe this is just some kind of an object that's already created. Maybe I have to import it and instantiate it. It doesn't really matter for this case, but I'm going to say washing machine dot start washing. All right. And that's all me as the client will see. Well, the washing machine then, it's going to wash and then rinse and then spin. I could add on extra subclasses, extra calls, extra objects that are a part of this method here. All right, so hopefully I'm not beating the idea into the ground here, but we can extend things very, very easily, and the client's not going to have to make any changes. Again, think of your client as somebody using your public interface, your public API. I have documented that my amazing washing machine class, all you have to do is call start washing and it handles everything for you. If I add in a smart feature, right, so let's add on sensing its weight, let's add on sensing the water that's in the machine. Maybe we want to be energy efficient and only put in a certain amount of water, or maybe you want to measure out soap at intervals, whatever washing machine's going to have to do. We can add on extra functions here and extra features and extra objects. Client is never going to know that's happening. They're just going to call start washing. So let's take a look at let's look at the consequences and the reasons to do it. So this is part of that specification for why we do things with design patterns, right? So using your system becomes a lot simpler from the users. And this is what I've been saying. It shields them from the backend. I, as the user, don't have to call, instantiate washing machine, then call wash, then rinse, then spin. Again, very simple example because there's only 3 things to do. But think of like a machine learning problem where you have to do a whole lot of moving parts, lots of matrix math, lots of loops for training and testing and all kinds of fun stuff like that. Or in the graphics world, it's not just image.draw, it's load this image into memory. You have to draw to a certain part of the screen updates at a particular refresh rate. You have to draw all the vertices and the triangles that make up an image, and it becomes a big headache. This abstracts things and makes life easier for everybody else. And this is kind of what I mentioned here, doesn't limit power users. Basically, you see all these methods and these attributes here, everything is public. So that's that plus. Again, it can be up to you if you want to hide some things. You're not limited there. But in the standard facade method, everything is open. So if you are a normal client, you only ever need to do this. But if you're a power user, meaning maybe you are modding something, maybe you want to extend it, maybe you want to hack into something, hacking being the kind of the maker type of thing where I want to do some kind of a DIY based thing. Well, I can call all these methods directly and add in my own stuff too. So we're not necessarily limiting access. Now, when do we apply this? Well, let's say we don't necessarily want to use everything, right? Just use what's publicly available. Maybe we want to encapsulate things and kind of put them into a component and abstract it away. We might want to extend something. So let's say we have this washing machine class where we have made a facade. Well, that's fine. Let's use the facade. And then after the facade is done, add on extra functionality. And maybe, just maybe, we start talking about that idea of technical debt where writing a facade is going to be easier than training everybody how to use your system. So we've made the next latest and greatest washing machine in GE's line of beautiful smart washers. All right. Well, I make the hardware. It's up to you, the developers, to make the phone app that controls our amazing new cool washing machine, right? It's going to be a heck of a lot harder for me to walk through the deep technical details of how the controller works. Instead, here's a facade that you just call, you push a button on your phone, okay? You make the phone app, I push a button to start washing. You don't care about all the stuff under the hood. Anybody, I keep throwing this term technical debt around. Does anybody know what that is? Because it's a it's become a buzzword in software engineering and industry, but it's a very real problem. Technical debt. Any guesses? Because I don't think we necessarily are going to be able to get deep into it, but it's something that you should be aware of as budding developers. Basically, so not seeing any responses, either it's a delay or the storm knocked everybody's power out, or we don't know, which is fine. Basically, you are doing something in the short term to get a task completed, but you're creating future work for yourself by taking a shortcut. So that's technical debt. And you can kind of think of it as, are you adding a little workaround? Maybe you're skipping adding a design pattern, just brute forcing something. Well, then 3 months down the road, when you go to test it, or when you go to extend it, it's actually going to be extra effort to fix it. Whereas if you had put an extra hour into the problem, you'd have zero issues later on down the road. And some companies will actually study technical debt for their projects, and it'll be a trade-off. Do we do a shortcut now to get our client satisfied, or do we spend an extra week developing, and then we tell them we're not going to have any issues further down the road? Or we can very clearly calculate it will take us a year from this point to resolve all these issues that came up just because we didn't have time to work on them. It's an interesting side discussion, I suppose, but I would recommend looking into it if you have not heard of it, because definitely an interesting topic. So here is, let's do the Python example, and then we'll look at the CPU. So we have our Singleton, and now we have our facade here. So I pulled this code off of Geeks for Geeks, which is a lovely website for learning some basic programming stuff if you've never checked it out. It's basically just somebody's blog, I think, but it's pretty good examples. So again, Python example here. I've got my main function. I'm going to instantiate a washing machine object, and then I'm going to call start washing. Well, what does start washing do? Washing machine is my facade. When I instantiate this thing, it's going to instantiate a wash, rinse, and spin object. And then once I want to actually get going, which is the start washing, which again we called from main, I want the washing object to kick off, then rinse, and then spin. Well, these things are all just separate classes themselves. So these are basically complicated objects that we are instantiating and then calling in order, right? And if I run this, I should have made my terminal size a little bit bigger, but it's neither here. Which part is considered the singleton? There are no singletons here. This is now a facade. So washing, rinsing, spinning. And we would kick off the actual mechanical pieces here. So this is a facade. So the washing machine itself is just a facade. To your point, though, we could make this singleton. Um, these subclasses, we could have them be singletons, right? So our washing machine, or sorry, washing, rinsing, spinning classes, we could force them to be only ever instantiated once, which our facade then could, instantiate those particular singletons and only ever do it one time, since we only have one washing machine, right? I could reverse the order here. So let's say that we spin first, then rinse, then wash. In this simple update I have made to the facade, I didn't touch the subclasses, right? Think of these being separate files, separate functionalities somewhere else that we're importing. I changed the facade. I haven't changed the user interface at all, which is this main method. And again, this is a very simplistic, tacky example where the only thing that we're doing is printing to the screen. But again, you just have to imagine that I just touched the particular facade class. No, thank you, VS Code. I didn't change the interface. I didn't change the subclasses or the, separate component classes. Let me undo this so that when I upload it, it doesn't put things in the wrong order. Separation of concerns is what we're getting here, right? If I was to have a big Java project, I would have one class file for my facade. I'd have a class file for each component. I'd have a separate project possibly for my client side. Just kind of depends how you implement things. All right, some other examples here. So this is actually going to be a C++, might even be a C version. Oh yeah, it's C++ because we have classes. Here's facade in C++. So we are abstracting out building a computer here. So I want to have calls to freeze, to jump, to execute. So if you took assembly, it should feel horrifyingly familiar. I can create a hard drive. I can create some memory. And then I can create a facade to simulate a computer here. So I'm going to have private variables for the processor, the RAM, and the hard drive. And then when I call the facade, when I instantiate it, I'm going to have a CPU, a memory, a hard drive instantiated. And then when I start, I'm basically going to go ahead and get going here. All right, so freeze the processor while everything loads in. Set up your RAM, set up your hard drive, jump to a particular address in memory to start executing code, and then actually run that. So if you squint at it, a class of the main method which calls different private methods acts as a facade. If you squint at it, sure. The idea with this is that it's not all encapsulated in one class, though. So you have the facade instantiating other classes. So the idea is if you have a big complicated program with lots of moving parts, the client just calls one thing, and then that one thing acts as kind of the arbiter of all the other classes. So yes, if you squint at it, sure. But the other key takeaway is basically these don't have to be private. They can be public. So that you don't necessarily abstract away things from your power users. So for a CPU, this is the facade. The client is going to basically call computer facade and then facade.start. So that's what you see here. This would what the client would be doing. Actually, is this? This is Java. What am I thinking? No, it's C. Okay. C++. It's been a hot moment since I've done pure C++. So yeah, there we go. This is all you, the client, would see. I, the API maintainer, have created all of this kind of simulated processor stuff, right? And this is the Python code that we talked about before. Okay, so I'm not going to make you jump technologies again, so we'll skip the slide, especially since we have 5 minutes. We didn't have enough time for Observer. Let's see how far we can get into Observer. Um, I guess let's talk Observer and then we'll end class because I want to get us moving along because we only have like 3 weeks left of class. Huh. All right, so Facade, hopefully we can understand where that would be useful. Hide the inner workings of your program from the common user. Observer is kind of the flip side of things. So let's say that we have some object, and this is kind of a nice little example. If you have kids or puppies or animals that you have to take care of, you have some kind of a subject that needs to be monitored. So this is some class object that's been instantiated, okay? And anytime something happens, you notify anybody tasked with observing it, and anybody being other classes. All right, so whereas Facade, we provide a central unified interface, we have a central unified class to get in here. Observer, this unified class is in charge of telling linked up classes that a thing has changed. So if we have a kid or we have a puppy or a kitty or, something that needs to be monitored, the kid falls out of bed, the puppy has grabbed the remote control and starts eating it. The cat is evil because that's what cats are, and has done something horrible. Well, we need to notify, let's say that I'm getting a Slack message, I'm getting an email message, I'm getting a video message that a thing has happened. Okay. And we see in very tiny print here priorities. So maybe depending on timings and things like that, we can prioritize messages going out. But this is a behavioral pattern, right? A thing has happened to a subject. We then notify observers. That is a behavioral thing. It's happening dynamically at runtime. The facade was structural because that's how we're building up our program, how we're providing access to key classes, key members. So basically what we have here, if you kind of look at this graphically, we have a list of observer objects. So I'm going to create an array or a list or a queue or whatever data structure you want to use of things that are going to get a message that an activity has happened, that an event has happened. And the kind of dry definition here is that an object has changed state. So the child has fallen out of bed, the puppy has eaten your slippers, the cat knocked a glass off the table, a state has changed, a behavior has happened. The dependents that are linked up are going to be notified. And the observer, so this list of things, will know what to do with that message when it comes in, right? If I get a message through Slack, or my Slack class is going to get a message, it's going to say ping me. You can make that a Discord observer if you want. I could get an email that would trigger sending the email functionality. I could get a text message, let's call Twilio or something like that. Send a video to obviously this is a phone, but if you've got like one of those Wi-Fi baby monitors or security cameras, send a video notification that something has happened. Could just be a motion sensor, right? So the idea here is that we have behavioral delegation going on. And the problem is that this list of objects could be different, right? So maybe they're not all going to be the same type. I'm basically just going to keep a list of things, and those things are going to have to accept this message coming in, right? So let's take a quick look at the design pattern in UML, and then we'll probably end here. So we have a little bit more complicated stuff going on here, right? So we have a subject, and we have a list of observers. So the concrete subject, concrete observer, these are basically instantiations of a particular object type. So if we have observers, this could be a concrete observer would be Slack, would be email, would be text, would be whatever type. The general observer class would just be, generic object. Okay. Subject, depending on your application, this would be the thing that you are looking at. Concrete subject would be the particular one. Baby, cat, dog, window if we're doing security monitoring. The key here is that we have a activity where we have a list of observers. Okay. And for every observer, we're going to update their state. So if we have a subject where thing has happened, we would call notify. We can attach or detach observers from here, meaning that, okay, I have a Slack observer, I have a text observer. Let's add in Discord because now I'm doing Discord. Okay, well, I would have a Discord observer object now. And that observer by itself would understand how to message me through Discord or through Slack. They'd each be in charge of their own functionality. All right, that's a good place to stop here, I think. Got at least through all three, so what we'll do next time is we'll finish up Observer, we'll start talking about Visitor, and you'll probably get your next homework assignment by then too. So just make sure that you get your Singleton posted up into Blackboard, and I will see you all on Wednesday. So hope you all have a wonderful rainy day. Let's get some party parrots in there, and I will bid you all a fine Monday. So, see you next time. Bye, everybody. Thanks as well. Have a wonderful day, everybody. Yes. So let me pull it back up here. Again, I really apologize because at some point Blackboard just stops tracking ordering of things. So it's in class assignment 5, and I've got it listed on the course information page. So you got till tomorrow night basically to get it in. But just whatever you posted in the Discord chat is what I'm looking for. So have a wonderful day. See y'all later.